all, let me tell you what is functionally graded material. Though you are aware of this functionally graded material, but still I want to give a brief introduction about functionally graded material. So functionally graded material is a advanced class of composite material where you can see that on the thickness direction the material changes from one material to another material very gradually and smoothly. Generally one side is metal is considered and another side ceramic is considered. As you know that ceramic is better heat resistance material, so in order to application in the high thermal area this kind of FGM material is very helpful, where the ceramic part will absorb the will protect as a thermal barrier and the metal part will bear the load of that component. So there are different things, advantages of the FGM material is provided compared to the conventional composite material. There are a wide range of application in the FGM materials: aerospace, energy, medicine, defense, nuclear. Now the different techniques of manufacturing the FGM materials, the some of the applications. Now as I told you that one side it is metal, another side is ceramic, so that from metal to ceramic variation can vary based on three different laws. One is simple power law, one is sigmoidal law, one is exponential law. Basically we use the simple power law for the simplicity of this operation. Here you can see that if this is n is power law index, if we use n as a 1, then it varies linearly with this graph. Okay, and if n is less than 1, then it goes through this, and I mean n is greater than 1 if it goes like this, and for n is equal to 0 it becomes purely metal, and n is equal to infinity it's become purely ceramic. So this is just brief introduction about the functionally graded material. You can go through the different journals and these things. Now we will determine the natural frequency of functionally graded material of a FGM block whose thickness are over here given as h is equal to 0.25 meter, a that means length 0.5 meter, b 0.5 meter, and ceramic material properties given this, and metal that is stainless steel mechanical properties is given with this one. And we will use the simple power law expression where and we will take n is equal to n is equal to 1. That means we will follow this linear variation from metal to ceramic. Okay, so in order to model these things in ANSYS, first we need to create a block where the dimension will be like length this with this, and h is, that is thickness is this one. Okay, so in order to make this kind of block in ANSYS, it is very difficult task to make the block and then divide the block in equal segments so that metal property can be given. So that's why I have used one simple macros to model these things. So as you know that the total thickness is 0.25 meter, so I have divided the total thickness in 16 equal layers, and each layer I will vary the material property based on the FGM power law index. So if I divide 0.25 by 16 layer, each layer gives this much amount of the thickness. So first block, that is length 0.5 with 0.5, and it starts from 0 thickness and goes to this thickness. And similarly the second layer, it will start from z is equal to this and end thickness over here, and by that way it will repeat and at the end of the 16th block total thickness we will achieve. So we will copy this one and we will copy, Control C, and then we will put. But before that I was doing something, so I will let me clear all the things in the my ANSYS. Okay, so first we need to add element, then I can put, because without adding element it will not work. So let's say beam, let's say solid 185 I am adding. Okay, then close. So you can see that one element type, that is solid 185, is added. Now if I paste this one, whatever I have written, Control C, Control V, and if I press enter, you can see that 16 different layers of each 16 different blocks it has been generated. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16. Now you can see that each block is separate quantity. That means if I select the top layer block, there is no connection between the second block. Like that, each and every block is separate quantity. So we need to make the attachment between two layers. That means there is two line. If I see that line over here, I can see that there are two line. You can see that there are two line is saying. So I need to make I need to join these things. So how can I join? There is one comment, or everything I have written in the macros also. So at the end I will give v glue comma all. That means it will glue the volume. So now you can see that there is only one line is present over here. See, only one line is present over here, no two number line is showing. Now if I see that once I have glued, the volume number has been changed. Like it previously it was 1 to 16. Now if I see that volume 1, then 17 starts. So I need to compress the volume so that I can get 1 to 16. And this is the comment. First I have to go v glue comma all, then num cmp volume, that means volume. So if now if you see that v list comma all, then you can see that 1 to 16 volume is there, 1 to 16. So there is no jump in number. Now if I come these things, so in my preprocessor stage I have added the element type, then I have modeled my the block whose thickness is h is 0.25, length is 0.5, and width is 0.5. Now we need to define the material property, and then we need to go for the mesh, then boundary condition, then we can solve this model. So you can see that this side is metal and this side is ceramic, and metal property varies from this phase, this below bottom layer to top layer gradually with n is equal to 1. Now here is 100% metal, here 100% ceramic. So I have done these things in Excel so that it can vary the metal property in gradual direction with this things. So I will share this Excel sheet also. So this is a metal where metal property is given is this one, okay, and this is the ceramic, metal property is given from here, okay. Now I have divided the each layer 1 to 16. Similarly, the volume fraction of ceramic, volume fraction of metal divided by each, and respectively for the first layer I can calculate the Young's modulus, ratio, density, and similarly for the 16th layer is this. So it is varying. Now I need to define the material properties over here, material model. Then I need to, for the material number 1, I need to structural, linear, elastic, isotropic, then Young's modulus, Poisson's ratio I need to put, and density I need to put. Once I will put these things, I can add new model, model 2, and the similar thing I need to do. So I have to go repeated things. So I can write one macro for this, and in that macro I can assign the material properties. So I have write the macro. I have already written the macro. It's MP. Let me check MP. Okay. So for the first layer, the Young's modulus is this one, and density is this one, and Poisson's ratio is this one. And for the second layer is this, the Young's modulus, density is this, Poisson's ratio is this. Poisson's ratio is 0.3 for all over the location, so it's 1. So similarly, layer 3, layer 4, layer 5. So once you use the next set of experiment, whenever you will change the material property, if you change n is equal to 10, then the parameter will change. So you need to copy each layer, the values of E, nu and rho, and you need to change over this location. So right now whatever the exercise that I am doing is for the n is equal to 1. So already I have copied the n is equal to 1 value over here, MP, and this is already defined. So you can do this exercise by manually, or you can write a macro and then you can easily import. So you see how I am importing the material property. Read input from, then my respective directory I will get, then MP is the material property that I have already. So I have got, you can see that it has come the 16 set of material. So respectively the density and all these things it has come. So my material property definition is also done. Now I need to mesh the model. So in order to mesh the model, I will go to mesh tool. This you can do manually or you can do with the help of macros, but I will show you manually because in my laptop the RAM size is not so good, so it will not run the huge quantity node size. So I will keep my node size as small as possible without violating the quality of the result. So let's say line. So the line in this segment I can check. So you can select the box and then this thing. You have to, while you are doing these things, you have to go by. I will show you again. Reset box, pick box, and then right click of the. Let me do it once again. Lines, box, then left click with your mouse, and then this amount of area line, it has been selected and selected. So for those line, put OK. Those line I am doing the elements division as let's say 15, so that then apply. So that is done. Now here each line I can define the division of the line. Okay, so I am doing, that is, let's say I am doing 1, because if I do 2, 3, then mesh size will be higher. So 1. Okay. Now if I go mesh tool, volume, hexagonal mesh, volume, hexagonal mesh, sweep, then pick all. What is the things? I have defined this side, but this side I have not defined. So v clear, comma all. That means I am clearing my volume. V plot, mesh tool, lines, reset, let's say 15. Okay, mesh tool, yes. So you can see that this direction 15 division, this direction 15 division, and each layer I have taken as 1 division. You can do 2, 3 if your machine is having good quality of RAM. Okay, now you can see that this is a V plot I will do. So each layer, this is layer 16, this is layer 1. So each layer now it is showing as a material property 1. So I need to assign the layer 1 with material property 1, layer 2 with material property 2, like that, layer 16 with material property 16. So first check that whether it is showing the material property correctly or not. This comma v. Okay, so this and this, you can see that all are showing material as a 1. So it is not correct. So I need to define. So how we can define? First we can select v cell comma r comma p, then I can give number 1. Okay, so it has been selected. Okay, so then select everything, selected volume. So this has, then e plot. Don't worry, I have the macro for you. E plot, then I can write e modif, comma p, then pick all. Then I can define, let's say I am defining material, for example I am saying, let's say 4. So now you can see that list comma p, it will show that material 4. So I have to go each layer wise. If I go for 32 layers, then it is not possible to do manually all those things. So for this I have write a macro. So let's say all I will bring all the things also v plot. Now assigning material property layer wise. Okay, so also then I will select volume 1, then that I will define as material 1. Similarly volume 2 I will define material 2. So like that 16 I will define. So I will put here these things, and you can see that it has been done. So also e plot. Now you can see that e list comma p, e list comma p, you can see that these will show the different material type, and it has been as per the order 1 to 16. So this layer 1 material type 1, material type 1, layer 2 material type 2, and layer 16 material type 16. So it has taken. Now I need to, so my modeling is done, my material property assignment is done, my meshing is done. Now I have to give, I need to give the boundary condition. So we will do a cantilever beam where one side is fixed and other side is free. So for this cantilever beam, in order to make cantilever beam, I need to fix this side node with all degrees of freedom. So I will select the node in cell comma r comma p box, then I will check with this. While I am doing this, you have to take the left click, okay, then okay. So in plot you can see that only those elements has been selected. Now I will come to solution, define load, apply structural displacement on nodes, pick all degrees of freedom I will restrict. Okay, so you can see that all degrees of freedom it has been restricted. Now alls e plot. Okay, so I have defined the boundary condition. Now I will go for solve the natural frequency for the first 20, first 15, whatever you like. So I have the macro for you. I will share the macro for the modal analysis. So if I want to extract 20 nodes, then we can do these things. I will share with you. These are the total things. It has been whenever you are running in batch mode in a big model, but for the small model we can put this only this much command have to solve, then it will Control C. I think everything I have done, nothing pending, so Control C and the Control V, then it will start solving. So solution is done. So you can see that, I will close this one, you can see that you need to come this window ANSYS APDL, and from there you can see the natural frequencies from block language iteration. So first natural frequency is this is in hertz. This is not non-dimensional, it is dimensional natural frequency. So whenever if you want to do the non-dimensional natural frequency, then you have to use the respective factor. So this is non-dimensional natural frequency. So first natural frequency this, second, like that it has been done. Now the thing is that we have determined the natural frequency for this condition. This is the plate geometry, this is the ceramic model, ceramic material property, this is the material mechanical properties, and this is the this was the thickness. Now if I want to do the same thing with the lesser thickness, that means if I want to do the thickness of 0.025, the same boundary condition, same thing, only the thickness I want to change from 0.25 to 0.025. Then what I need to do? I need to go from as fresh, so it is tedious job. So we have the something, so we can do these things very easily. So what is the factor of decreasing the thickness is 10 times. Okay, so 10 times is decreasing the thickness. So what I will do, I will also plot. So there is one option over here, scale volumes, pick all, then scale factor. for x direction I will keep as 1, y direction I will keep as 1, and z direction I will put 0.1. Then my thickness will be reduced by 10 times. Okay. Now this needs to be volume and meshed and moved. That means it is not copied. The original will be deleted and this will be new one will remain. So volume as well as mesh. If you do the volumes only, then mesh will not come. You have to remesh again. So volumes and mesh only, both. Now okay. So you can see that the thickness it has been reduced. So as I told you that you can keep this each layer number of division 1. So here also number of division will remain as 1. So you can see that this. So boundary is also, condition is also already there. Now what you need to do, you can check that whether it's is comma p. So each layer is giving different material type. So material type it is given 15, 16. Why it is 15, 16 and 11? Because 16, 11, 12, let's say b is comma all. Okay, so it's perfect. So from volume 1 to 16 is there, so that's why material property is also giving 1 to 16. So let's say this will give 1. Okay, perfect. And this top will give 16. Okay, perfect. So what we need to do, we need to just run this one, copy from here to here, Control C, and I will put V, then solution is done. So you can see that the natural frequency, it has been changed like this. Okay, now you can do similar kind of exercise by changing the dimension in x, y or z, whatever you like, and also whatever the values of n you can put, and you need to take the material properties from here and you need to put in the assigned material, you need to put in the material properties location, you need to put the respective material properties, and you can run the model. Now this same thing can be exercised for the sigmoidal power law also and exponential power law. So if you need, then I can share the Excel file to which has been automatically calculated the material properties for the sigmoidal power law and exponential power law, with having the provision of n is equal to infinity to 0. Now instead, if you want to do the similar exercise for the other kind of metal, then you need to change the material property of the ceramic and metal in respective location. So by this way you can calculate the natural frequency and you can do these things. Now once you have calculated the natural frequency, now how you can check the deformed shape and the mode shape, so that I will show you. General post-purpose processor, then read result by pick. So if you are plotting for the first set, that means for the now the condition it has been h is equal to 0.025, not 0.25, because we have scaled the z direction in with scale factor 0.1. So if I select this one first set, read, close, then we can plot results from here also, or we can from the macro also. Control plot nodal solution or elemental solution, then degrees of freedom, stress. So z component displacement if we put, then we can get like. So the several factors, several stress, strain, whatever you like, you can do from here, and you can take the respective plot. So there are different plotting macros also available, where you need not to plot the manually. You can write the macros, and whatever the result you need, it will directly it will automatically generate the result, and it will copy in your file as a JPG file.